Hello guys, how are you today? I hope you are fine. So today we are going to talk about the line graphs and then about its equation. So let's get started. Before starting talking about the equation of the straight line, I want to introduce you some spatial line graphs. So here you can see them. So let's start from the first one. So here x is equal to 3. It is written x is equal to 3, which is not common equation that you have seen before. Generally, you see that the equation needs to be y is equal to 2x plus 5, y or f of x is equal to 1 over 4x minus 3, and generally you have one independent and one dependent variable, and these two variables makes a function. So generally you have seen like this, but this seems to be a bit strange that x is equal to 3. So how can it be a line? Isn't it strange? I think it is, and so now I'll explain how the line looks like. So uh, in section 6a, I explained you we have three different types of variables: independent, dependent, and fixed variables. Do you remember it? For remembering it, you should watch section 6a. So if you remember, it's okay. So this kind of equation represents fixed variable. You see, x can't change. Y, we don't have any y even here. You see, and x can't change, and x is fixed on number 3. X is always 3. So there is only one way to represent this equation, and that way is like this. Let me show you. This is 3, right? And this is x-axis, as you know. And this is y-axis, right? So, and this is 3. 1, 2, and 3. So x is always 3. It doesn't care about the y, the white number y has, or anything else. So the one way, only one way is that's it. You see, this line represents this equation. X is equal to 3. You see, here we have a lot of points here, right, on this line. You see? But for each point, for example, let's see this point. This is 1, actually 3, 1. Here is 1, right? Here is 2, here is 3, and here is 4. This point represents 1, 3, actually not 3, 1, right? So this point represents 3, 2. This point represents 3, 4. No, 3. Right? So, and let's see about this quadrant. For example, this point. This point represents 3, negative 4. So, in each point, you see, we have the same x. 3 here, 3 here, 3 here, and 3 here. But our y, the numbers on y coordinates are different. It doesn't matter. Just x is fixed. X is always 3. So x is equal to 3 means we need to have a line parallel to y-axis and needs to pass through number 3 on x-axis. Clear? With the same idea, we can say that, for example, x, let me write here, x is equal to negative 2, right? X is equal to negative 2 should pass through, this is 1, this is negative 2, right? It needs to be like this, because this is negative 2 here. This is negative 2. No. Oh, sorry. Let's do it again. Okay. This is negative 2, right? Negative 2. So my line needs to be like this. Okay? Needs to be parallel to y-axis and pass through the negative 2 on x-axis. Is it clear? I hope it is. So let's continue. Our next strange function, a bit strange function, not, we can't say function because we don't have any variables here. This equation is y is equal to negative 2, for example. So here again, this is a kind of fixed variable, fixed. Y is fixed, y is locked, okay, locked, can't change. So is equal to negative 2. So with the same idea as before, we should find first where is negative 2 on y-axis, right? So negative 2, this is y-axis, this is y-axis, right? This is x-axis, right? So a negative 2 needs to be here. And then y is equal to negative 2. And we need to find the collection of some points, some ordered pairs, okay, on this coordinate plane, which has y coordinate as negative 2. Okay. So this line needs to be like this. No. Okay. And this is negative 2. This point is negative 2. So, and for each point on this line, for example, this point and this point maybe and this point, all of them has negative 2 as their y coordinate. For example, this point is 3, negative 2. This point is 2, negative 2. This point is actually negative 2, negative 2. This point is negative 1, 2, 3, 4, negative 4, and negative 2. You see, for each ordered pair, for example, this point we said first, we have 3, negative 2, and for example, with this point we have negative 4 and negative 2. And for example, let's say for this point we have 1, negative 2. Okay, and so for all of them we have negative 2, negative 2 here, and negative 2 here. Okay, the y coordinates are always negative 2 because the y coordinate is fixed, is locked with number 2. So with the same idea we can say that for example y is equal to, let me write here, with the same idea we can say that y is equal to, for example, 5, okay, or 4. Y is equal to 4 needs to be, this is 1, 2, 3, and 4 here. It needs to pass on 4. No, not like this. This is y is equal to -2. Actually, y is equal to 4, right? Y is equal to 4. So this line needs to be parallel on x-axis, this x-axis. So I need to find 4 on y-axis, not on x-axis. 4 is here, 1, 2, 3, and 4. 4 is here, right? So my line needs to be like this. Okay, this is 4. Clear? Okay. And the last one is similar to you because we have worked with this before. Y is equal to x. This is a function because we have independent and dependent variable. Independent variable is x and dependent variable is y. So, but we don't have any number, for example 2x plus 5, 1 over 4x minus 5, or 2. We don't have any numbers, just x and y. So, and the function and the rule says that for each input you have the same output. If your input is 1, your output needs to be 1. If your input is 5, your output needs to be 5. Okay? Let's make our ordered pairs first. Okay. For example, 1 and 1, because y is equal to x, y is equal to x. For example, -2 means it needs to be -2 as well for output. For example, 3 and 3. Okay? So let's plot these points. 1, 1 needs to be here. -2, -2 needs to be here, right? So 3, 3 needs to be, 3, 3 needs to be here. And just the last step is to connect these points. Let's do it. Okay. That's the graph of this function y is equal to x. Clear, guys? Okay. For this little introduction, let's go a bit deeper and let's talk about the equation of the line. I mean straight line. We are talking about a straight line. So and guys, you can ask if you have some problems, if you still don't understand something. You can ask in comments. Ask in comments and I'll try to explain it. Guys, generally, before starting talking about the equation of the line, let me first explain you actually some line graphs. Okay, and then let's see how they are changing. Okay, I'm here, don't worry. Okay, so here we have a function, guys, you see, and here we have its line, and here, guys, you see that we have two numbers in our equation, right? This is one number in front of x, and this is another number. We can add or subtract. Okay, and these numbers affect the position of the graph on the coordinate plane. Okay, for example, if it is 2x plus 2, the line will change its given position, the previous position. It will change. Okay, so and now we'll try to analyze how these two numbers affect the graph of the line when they are changing. Okay, let's see. First, let me delete 1, and we have just number and x. Number multiplied by x, a number in front of x. So 2x. Okay, 2x y is equal to 2x passes through the origin, okay, 0, 0 here. Okay. And so, for example, you see, this is 2. If we put 2 in this function, it will be 2x, it will be 4, right? And you see, this is 4. This is 4 here. This is 4. So, and then, let's see what happens if we change the number. Okay. Let's write 5x. Or let's write 4x. Let's write 3x. Let's write just x. Let's write a fraction if we can do, I don't know, maybe 1 over, yes we can do, 1 over 2. You see? And let's write 1 over 4. You see? Let's write negative numbers. Let's try negative numbers. So, okay. This is first quadrant, right? This is first quadrant. This is second quadrant. This is third quadrant. And this is fourth quadrant. Okay, now. If x is positive, or the number in front of x, is positive, then our line needs to pass through quadrant 1 and 3, as you see. If it is positive 4, it is always like this. If it is positive 6, it is also like this. If it is positive 2, it is also like this. But if it is negative 3, oh, oops, they changed. You see? Now our line passes through second and fourth quadrant. Okay? It is the same for all negative numbers. For example, negative 4. For example, negative, let's try fraction 1 over 4. Okay? Again, second and fourth quadrant. There, it's passing through. Okay, so as you see, by the changing the value of the number in front of x, the steepness of our line, okay? Let's say this is our line, okay? This is our line. The steepness means, you see, orientation, and it's making a kind of degree between x-axis, right? This is more steep. This is less steep, okay? Less steep. This is more steep. So, if the number is changing, I mean the number which stands in front of x, the steepness of the line is changing. Steepness, okay? It's changing over 360 degrees. It's changing. Steepness is changed, okay? So it means that this number affects the steepness of the line. Clear? Let's see how what we add and subtract in the next just time. For example, 3x minus 4 or 3x plus 2. Let's say these numbers, how they affect on the line. Let's see, guys. For example, let's try just single x plus 5. Okay? X plus 5. Let's see. Oh, x plus 5. And x plus 1, x plus 2, x plus 4, x minus 5, x minus 4, x minus 3, x minus 1, x plus 10. You see? X plus 1. Okay. Now I think it is clear to you that what this number affects on the graph of the line. So while just the number in front of the x changes the steepness of the line, okay, but the number that we add, it changes, actually slides this line. For example, if we add x plus 1, it slides one step up. If we add x, if you write x plus 3, it changes its previous position 3 step up. Okay, the number at the end slides the line up and down. If you write -1 or x minus 1, it will come one step down. Okay, if you write -4, it will come 4 step down. Clear? Okay. Just finally, the number in front of x affect the steepness of the line. Okay, steepness of the line. But the number at the end affect, actually try to slide the line up and down. Clear? Okay. So let's come to our notes. Sorry. Okay. Here. So no, we don't need this, I think. Okay, guys. The equation of the line is like this. Y is equal to m multiplied by x and plus c. Okay? As I explained before, we have two numbers. One number is in front of x, which is represented by m here, m. It doesn't matter, just m, maybe n, maybe a, maybe b, c, d, e, f, c. You can do it. But generally, for the being understood for everyone, so for example, somebody's name is Arif and maybe somebody's name is Sevda or Rahim, or for example Nemat, okay, and its name is M. That's it. It is easy for us, for example, for each different classes. If somebody is talking about the equation of the line, if somebody tells M, then everybody understands that which M is this. But if we will work just maybe I called it as N and somebody else called it as B, and then we'll confuse what is M, what is N, or what is B. Okay? It is just accepted that let's write M. Let's represent the number which is in front of the x like M. Okay? That's it. They decided to represent it as M. M is a kind of number. It can be fraction, it can be negative, it can be positive, okay? So, and the next number, if we add and subtract at the end, and they called it as C, okay? This is M, and this is C. Both are numbers. They are numbers. Shortly I write NUM. They are numbers. They can be fraction, they can be positive and negative as well. Okay. Look what's written here. M, and it's written here slope. Okay, I said that the number in front of x affect the steepness of the line, which is called in math as slope. Okay, not steepness, just slope. Okay, if we are talking about the slope, it means that we are talking about the steepness of the line. Steepness. Clear? Okay. This is M, this is steepness, and C. C is called as y-intercept. Y-intercept. The y-intercept means intersection with y-axis. Intersection with y-axis. And now I'll go back to our algebra calculator and I'll show you that for each equation of the line, for each function of the line, if the c is, for example, 5, then line needs to pass through the 5 on y-axis. If it is negative 2, the line needs to pass through negative 2 on y-axis. That's why this is always y-intercept. I mean, C represent the intersection with y-coordinate. Let's see it. Let's see it. Here. Okay. So, let's try first x plus 4. You see? Our line passes through 4 on y-axis. This is y coordinate, right? Y-axis actually. And we have a 4 here. Clear? Let's try another one. Let's write, for example, negative 2. Okay. And again you can see that our line passes through the negative 2 on, again, on y-axis, not on x-axis. On x-axis it is positive 2. So let's change the numbers here. I mean, let's change the slope. Let's write 5x. You see, again it is passes through negative 2 if we change the numbers in front of x. You see? Let's try for another numbers. 5x, for example, let's write not 5x, it's 3x. Okay? 3x plus 3. Oh, you see? Now it has passes through 3. This is 3. Again on y-axis. So for this reason, we can easily say that C represent the y-intercept, and y-intercept means intersection with y-axis. Intersection with y-axis. Clear? Okay. Let's turn back to our notes. Okay. Okay. Now, y-intercept means, so this is our equation of the line y is equal to m multiplied by x plus c. M represents steepness, c represents y-intercept, and y-intercept means intersection with y-axis. Okay, here I just again try to explain what's y-intercept, what's x-intercept, and if we have a y-intercept, we have x-intercept as well. This is x-intercept, this is y-intercept. Y-intercept is intersection with y-axis, this is y-axis. X-intercept means intersection with x-axis, okay? And for example here, y-intercept is 0, 6. And here x-intercept is negative 4, 0, okay? So, and at the end, I want to talk about increasing and decreasing process, which we need to able to read from the graphs, from the line graph. We need to able to understand which type of graph represent increasing, which type of graph represent decreasing, and which kind of graph represent constant, no change. Okay? So, as you see from the picture, here, The blue line is representing increasing process. And so if the line segment is upward, okay, it means that something is increasing here. The amount of the money is increasing, or temperature in the room is increasing, okay, or progress of your study is increasing. And so in the green part, you see the green part is parallel to x. Its values is fixed on 1. This is 1. You see 1. This is fixed. Always is 1. For negative 2 it is 1. For negative 1 it is 1. For the independent variable, for the input, it is always 1. Okay? So this kind of graph represent constant changing, no change actually. If there is no change, your graph needs to be parallel to x-axis. Okay? Or your line needs to be horizontal. Okay, again we have a blue section, and this represents increasing because the line is upward. Okay, upward as a plane. So, and here the red one is downward. Okay, landing, like plane landing. So this kind of graph represents decreasing process, decreasing action. Okay, decreasing, upward increasing, horizontal line constant, and downward decreasing. Clear? Okay, I hope it is. And lastly, let me quickly review our keywords from this section. Okay. So, why it doesn't work? Okay. So, our keywords. First one is increasing, just I said, upward, decreasing downward, and constant, parallel or horizontal, parallel to x-axis or horizontal line. Slope, just I explained, it is steepness. It is steepness. Steepness, okay? And slope represented by m, okay? X-intercept means intersection with x-axis. Okay, this point is x-intercept. Y-intercept means intersection with y-axis. This is y-intercept. This point is y-intercept, okay? This is x-intercept, this is y-intercept. And so vertical line. Vertical line, you know what is vertical line. Vertical line is like this, which is parallel to y-axis. And the horizontal line is like this, it is parallel to x-axis. Clear? Okay. So guys, I think uh, that's it. So our special line graphs, and then slope and y-intercept, and increasing, decreasing. So let's finally at the end, let's do practice. Okay, here. Okay, we have a line equation of the line. Okay, we have two numbers here, -4 in front of x and +4 here. So, and we are asking to find the slope of the line and y-intercept of the line. So slope is m, and let me write first the general equation of the line. Y is equal to m multiplied by x and plus c. Okay? So as the number in front of x is -4, and since this -4 represents m, and since m stands for slope, so our slope is -4. And since c is positive 4, it means that y-intercept needs to be 4. Okay? And if we need asked to write its coordinates, we should write 0, 4. Okay? Okay, here, let's see what's going on here. And we are again have the equation of the line. And our m is here negative 5, so slope is negative 5. And the c is negative 3, so y-intercept needs to be negative 3. Okay? And guys, please write in comments what's the correct answers for this example. 1 over 3, negative 1 over 3, x plus 1. Write slope and y-intercept in comments. Okay? I'll like it if it is correct. So, and let's do another example for reverse operation. Okay, now guys, we have a slope. We have given a slope and we have given a y-intercept. We need to form an equation for this given line. So let me first write the equation of the line. Equation of the line is like this: y is equal to m multiplied by x and plus c. Okay? So for having the equation of the line, I need to find m and c. Just x and y, they are variables. They need to be as itself, and x and y. So let me write y is equal to some numbers here. I need to write m multiplied by x and plus I need another number which needs to be y-intercept. I need to write here. So let's do it. Slope is 5, okay, and slope is m, which stands in front of x. So I need to write here 5. And y-intercept is negative 4, and it needs to be c. So I need to write negative 4 here, right? And finally my equation is like this: y is equal to 5x minus 4, because plus minus needs to be minus. If both was negative, then it needs to be positive. I think as you know this rule. So my equation is y is equal to 5x minus 4. Let's do this for the next one. Slope is given, it is negative 8, and the y-intercept is 8. Actually, my equation is given here. M of x. Here it is written mx plus b, but it doesn't matter. It is cb, just generally c or b, but m doesn't change. M stands for slope. So y is equal to negative 8 multiplied by x, okay, because m stands in front of x, and plus 8. Okay, that's it. This is my equation for this slope and y-intercept. Clear, guys? And for this one, write the correct answer in comments. You have a slope negative 1 and you have a y-intercept as negative 12. I like it if it is correct. See you guys. Bye. Have a nice day. I hope this video is useful and will be useful for a while at least. See you guys. Bye.